In this video, we'll be taking a closer look at molarity, or molar concentration. Molarity is the most common way that chemists describe the concentration of a solution. It is calculated by dividing the number of moles of solute present in a solution by the total volume of the solution in liters. Here's a practice problem where molarity is calculated. What is the molarity of an aqueous solution containing 35.8 grams of sodium chloride dissolved in 1.5 liters of solution? Since molarity is a representation of the concentration of a solution in terms of the moles of solute divided by the liters of solution, the first thing we do is convert the 35.8 grams of sodium chloride to moles of sodium chloride. And since a conversion is necessary, a dimensional analysis conversion chart will help. Place the 35.8 grams of sodium chloride in the upper left-hand corner of a conversion chart. Then, bring down the units of grams of sodium chloride and put the molar mass of the sodium chloride, which is 58.44 grams, in the denominator. Next, put 1 mole of sodium chloride in the numerator. The units of grams of sodium chloride cancel since they appear in both the numerator and the denominator. And when we multiply 35.8 times 1 divided by 58.44, we find that we have 0.613 moles of sodium chloride. In this problem, we were already given the volume of the solution in liters. So we divide the moles that we just calculated by the 1.5 liters of the solution to get the molarity. And that answer is 0.41 after rounding to two significant figures. This solution could be labeled as 0.41 capital M NaCl, which would be read as 0.41 molar sodium chloride solution. Here's another practice problem involving a molarity calculation. A 110.5 milliliter intravenous solution contains 5.28 grams of glucose. What is the molarity of this solution? The molar mass of glucose is 180.16 grams per mole. The first step is to convert the mass of the solute into moles. We do that by taking the 5.28 grams of glucose and putting it in the upper left-hand corner of a conversion chart. Then we bring down the units of the grams of glucose to the denominator and put 1 mole of glucose into the numerator. That allows us to cancel the units of grams of glucose because grams appear in both the numerator and the denominator. Once we do the calculation, we will be left with moles of glucose. When we multiply 5.28 times 1 and then divide that by 180.16, we find that we have 0.0293 moles of glucose. The next step is to convert the volume of the solution to liters. Notice that the problem gave us the volume in milliliters to begin with. So to convert 110.5 milliliters to liters, simply divide 110.5 by 1,000. And we find that we have 0.1105 liters of the solution. The last step is to divide the moles of the solute by the liters of the solution. And 0.0293 divided by 0.1105 equals 0.265 after rounding to three significant figures. We represent that with a capital M, which indicates molarity. This solution could be labeled 0.265 capital M C6H12O6, which would be read as a 0.265 molar glucose solution. Now here's one for you to try. Calculate the molarity of 1.85 liters of a solution that contains 1.48 grams of dissolved potassium iodide. When you're ready, press pause and give it a try. Once you've completed the problem, press play and see if you got it right. Did you get 4.82 times 10 to the negative third molar potassium iodide? If you did, good work. If you didn't, let's go back and look at how we got there. The first thing we did was take the 1.48 grams of the potassium iodide and put it in the upper left-hand corner of a conversion chart. Then we brought the units of grams of potassium iodide down and used the molar mass from the periodic table to convert to moles of potassium iodide. And 1.48 times 1 divided by 166 gave us 8.92 times 10 to the negative third moles of potassium iodide. Since the question already gave us the volume of the solution in liters, all that was left to do was to take the moles of potassium iodide and divide that by the volume of the solution, which was 1.85 liters. When we divided those two numbers, we got 4.82 times 10 to the negative third, and that's the molarity of the solution. If you'd like more Chemistry Matters, go to the home page where the entire series is available to you.